Hello.
You have a track record of productive.
That's one of the reasons, right? Is it too loud? Is it too loud over here? I'm David. Is it too loud? It's not too loud. Is it perfect? Is it good? Should it go loud? Should it go lower? Louder? Lower? Perfect. Okay. You should here. You see the volume coming in over there. Is that it? Could be.
I just wanted to make sure it's kind of there.
So you share the link.
Hello. Testing. Yeah, today. First of all, welcome back, everybody. We're very excited to be here. Today we had to blow all the dust off the mic and the camera and see if we can roll down the projector and everything works. But Baruch Hashem, we're up in business. Stream is running. I'm not going to take too long over here. We'll jump right into Eli. Just before we start, I just wanted to first of all give a big mazel tov to Naftali Hilgenheim. Double mazel tov. I know we're belated. Double mazel tov, first of all, on his marriage and having a baby. Usually when you do that, it's like a little shady, but over here, since we've been out so long, it makes sense. And I also wanted to give a shout out to Amram Steinmetz for there he is, for providing these fantastic badges. Thank you everybody for putting them on. I think that's great. And so we'll just jump right in over here with Mr. Golding, Eli Golding, who will teach us how to infer all the types. TypeScript, for all those who don't know, it's awesome. You should get on that train. Okay, great.
Wait, don't. No, we're good. No. I thought you were holding that. By the end of the talk, we'll all be on the TypeScript train. So, all right. Thank you so much, Mordechai, for that wonderful introduction. Hello, everyone. For those who don't know me, Eli Golding. This is too loud. Senior engineer. What? I know, but I hear myself. Yeah, a couple of new faces here. So yeah, Eli Golding. Last time you heard from me, last time I was up here, I actually worked at Quality Bath, but now I'm working at Northwestern Mutual, selling.
What did you sell at Quality Bath?
What was that?
What did you sell at Quality Bath?
At Quality Bath, we sold expensive toilets. Now I sell expensive life insurance. So it's the same thing. I just like to rip people off, whatever. Okay, just a quick poll by the show of hands. How many people are using? We'll start from. How many people are proficient in TypeScript? Like are using TypeScript every day and are considered TypeScript pros? Wow. Okay. How many people never ever used TypeScript before? And this is brand new. Okay. How many people dabble with TypeScript but whatever? Okay. So it seems like that's where flow does not count, not even a little bit. Okay. So just a very quick introduction. Obviously, this talk is going to be PowerPoint completely messed up my whole, so I'm not in present mode because PowerPoint just made my computer explode or whatever. But so obviously, I'm going to talk about TypeScript, and obviously, I like TypeScript very much, and that's going to come out in the course of the talk. I'm not going to lecture in terms of the benefits of TypeScript, what it is. We're just actually going to jump into code, and so hopefully let the code talk for itself. But the story I want to tell is really about the developer experience that you get when using TypeScript, and not necessarily the benefits of type safety and stuff like that. So I'll tell you what I'm not going to talk about. I am not going to talk about the fact that you can't have runtime errors if your code doesn't compile, right? I'm not going to talk about that because it's just simply not true. And this is probably the most important. I have this terrible habit of just not doing slides and only doing memes. Therapy is expensive. I can't knock it, so whatever. So yeah, TypeScript, this is the most important slide that you'll ever see in terms of starting out TypeScript. In my experience with working with people, how many people work with static type languages like Java, C#, and stuff like that? Okay, not a ton. But the biggest, I guess, mental hurdle for people coming from traditionally static type languages is the fact that it's just TypeScript at the end of the day gets compiled down to JavaScript, and what actually gets run is just JavaScript. There is no type checking at runtime. If you want type checking at runtime, you have to. There are some TypeScript libraries that sort of add a runtime. What? Or use PHP? Why would you do that? Oh, did they? But really, so. Therefore, I'm not going to talk necessarily about type safety per se. There obviously you do get a lot of type safety, but it's not impossible to sort of still get runtime errors even when you use TypeScript. It's just something to bear in mind once you start down your TypeScript journey. So I'm going to focus on hopefully what I hope to convey is the developer experience that you get. And I did not start my timer. Developer experience that you get when developing with TypeScript. So enough talk. We're going to code. If I could find. That's just another meme. I told you, it's a terrible habit of mine. Okay. All right, can everyone see? Does it need to be bigger? Even bigger?
Ellie, what editor is that?
No.
I'm not sure. It's what they installed on my computer. It's good? Okay, so this is too big, right? This is better. This is perfect? You can see in the back? I'm David, you can see it? Perfect. All right, ready? So, we're just going to quickly take a quick crash course on the language. It's on just like the very basics of the language before we actually get into like what I want to talk about, which is like how awesome, like the awesome parts of the language. So it looks very much like, is my Vim working? My Vim's working, yes. It looks like JavaScript, except that you add this type annotation, right? In Java, C#, I think it comes before the identifier. Here it's colon and then the type. So we have all different types. So we have string. String, my name is Ellie. If I try to change my name to something that's a number, so you see your editor, VS Code, and every editor as well. But will tell you type number is not assignable to type string. So your editor, right off the bat, when you use TypeScript, your editor is very helpful, and we're going to be looking at these little hover thingies a lot, these little tooltips a lot. But you see, type number is not assignable to type string because it's because that's type string. Obviously, we have numbers, we have arrays. Arrays is you do the type and then the open bracket. We're just going to get some basic syntax because I don't want to lose all of you right away. And then you have an array. If you try to like add to that array, if you try to give a string, so right away it's going to say nope, same error. Good. You can make a tuple type. Tuple type is not really a type. There's going to be a whole other talk whether it's tuple or tuple, but that's not for now. A tuple is literally just like an array where you're specifying, like, it's just an array type, but you're specifying the types at the different locations. So this is where, so far everything's pretty straightforward. It looks just like JavaScript, it's just we've got these little type annotations. We also have something called, well, you know what, before explaining the fact that that's a union type. What type is this? This is not a type string. It is the type hello. It is the type string hello. We have literal, the Chassan Kala kindly asked that you shut yourself up. We have string literal types, meaning this is the type. It's not a type string, it's the type of the string hello, which means the only thing that could be assigned to greeting is hello, and if you type goodbye, it's going to say goodbye is not assignable to type hello. So we're already sort of like diverging off like the regular, like the TypeScript does types, they do types differently. It's a type. Now, if I want to be able to have it hello, so I could have a union type where I could give it like choices, where the union type where I could say, oh, this could also be, I got to spell it right. It could also be goodbye, so then that goes away. So that's where you have like union types. Union types are very important. It's just basically just a choice. It's not an enum. It's a choice of types. TypeScript does have enums. I'm not going to talk about them because I don't like them. No, because it's just not. It doesn't fit into the what's called. But TypeScript they do have enums. But this is a union type is just it's what do they call them? The sum types, right? It's just like it could be either this or that. Like you just have a bunch of choices to choose from. So it could be that.
String and a number?
What? You could be a string and a number. I could say I could be a string and a number, so then this could now be a number. It could be anything you want, right? It could also be a literal number, right? Right? And then if I change this to 1, 2, 3, 4, it will complain, right? So any literal value can be in your union, and any just regular type. My point is that literal values are a type in itself as well. That's the point over here. Let's keep on going because we have a lot to talk about. You can also do objects. You could just inline that type. So Morty is 16. I just took a guess, but I might be off by 1 or 2. So then you do that. So functions. You do the annotation within right next to the argument over there, and then the return type comes after. But again, you got this colon type, and that's that. So you get type safety with functions as well. Good. What? Arrow functions, you could have types for arrow functions as well. It goes on the variable. What's an arrow function? It's just a value, right? Functions are values. Const say hello to AD. I'm not going to spell out your whole name, but yeah. You could just say just the same thing. I'm going to cut and paste. I'm lazy. and equals, and then you just say name and string or something like that. I'm not sure. I'm not sure. It's just I'm taking what? Just return what? Return a yeah. Yes, you could have a what's it called? I'm trying to rush because I've given this talk before and I gave it twice before and I haven't done it in less than 45 minutes. So I'm going to try to rush a little bit, but you still ask questions, please. Still ask questions. If I don't think that it fits in the flow, I'm just what's it called? So type aliases. So here we got a new keyword. This is the first time we have a new keyword. We're going to see a couple of new keywords that TypeScript introduced more than JavaScript. I know I said it's just JavaScript, not just JavaScript. It's awesome JavaScript. So we have type alias. So I'm not going to talk about classes or interfaces or enums for that matter. They're all there. You could use them if you want, but there's a lot of reasons why you might not want to use them. I'm not going to lecture you. I'm just going to show what types are capable of, and hopefully, hopefully you'll make your own decision. So a type alias is basically that same object that we had over here before. It's just we sort of inlined it. So now we have another. We assigned it to a type. Excuse me. What? And the Zeta with the stender over here. So again, so now for the annotation, instead of like the string or number, we actually just give that type alias. So we took this type, the same type that we inlined over here before of this object, we assigned it to a variable, if you may, right? Type person, it's a variable in the domain of types. It's not in the domain of values, it's just a type variable. And we're good to go. So now that same function, say hello to person, you could type it, you could annotate it on a person, and then you have that. Okay, good so far? Any questions? No questions. Or maybe questions. Generic. So this is the first. This is where I know for sure by me. What's there? Oh, those. I know for sure by. By me, generics was like the basic types and annotating your JavaScript with types was pretty straightforward for me. Generics, I always had a hard time. I remember my first week in quality math, Boomy trying to teach me generics and just didn't go. So I'm going to try my hardest. So what's a generic? So over here, let's say you have a function. This is just an identity function. It takes an argument, returns an argument, does nothing. It's just for demonstration purposes. I'm sorry for any functional programmers who just got insulted by that statement. But identities, yeah, it's just for demonstration purposes. But let's say so over here I typed it to a string and it's returning a string, obviously. But what if I wanted to take, I don't really care what type it is. I don't really want to, I want to say that it could be sort of any type, or it should just be whatever type you pass in. Like, I want this to be more, I want this to be, besides a string, it could also be a number, but then I have to, so I'm giving choices over here, like it could be a string or a number, but now if you look at the definition, it returns a string or a number, which means that whatever you pass in, so if I were actually to call it, so identity foo, you know what, let's say const, thing is identity. So this type over here, it's saying it's a string or a number. But it's not. We know it's a string, right? We know it's a string. So is there a way, generics basically say, the same way you could assign a variable to, the same way you could in let's say, when we program, we have variables that sort of are like placeholders for the value that's going to come later on, right? So args is going to be foo, but when we define the function, we don't know yet what the argument is going to be. So the same thing we could have with types. You could basically assign a variable. You could assign a variable that's going to be the type later on. So how do we do that? So I'm just going to delete this type for now. And oops. Now, so the same way I created a variable in between the parentheses, and that's functions, the way we learned on the first day that we learned that a program, we learned that function arguments go between the parentheses. Type parameters go right before the parentheses in these little brackets. And I could just name it whatever I want. I'll name it I'm going to name it, I'll name it, type of arg. It's the type of my arg. And now, I now have the type of my arg. Now it's complaining. It says, whoa, you said you're returning a string or a number, and you're just returning this type of arg, which we don't even know what it is. So there's two things I could do. There's two things I could do to make this compiler happy. I could constrain this I could constrain it by using the extends keyword. Extends, there we go. I could say it extends a string or a number, and now the compiler is happy because I'm saying it could be anything, it's a variable, but I'm typing my type variable. Super meta over here, ready? I'm sort of typing my type, by extending it, you're constraining, it's a type constraint. So I'm narrowing the type and I'm saying, no, this type, it could be, I'm not saying what it is because it's gonna be later on, I'm defining it the same, I'm gonna define it when I actually call the method, but I'm constraining it right now to a string or a number. Or I could just return the type. And that's better, right? So now when I use it, I want, how do you declare it at runtime? Oops, what happened here? Stupid VS Code, I'm telling you. I could say this will be, if I say that this will be a number, so now it's going to complain, type string is not assignable with type number, because now when I call the method, same way I'm assigning the value foo to the variable arg, I'm assigning the value of the type number to the type parameter of type of arg. Are we good? This is super important to understand because the rest of the talk is going to be very heavy about generics. You do not need to put it in. What, do you, ask that again? Yes, if you don't put it in, it will infer. That's the name of the talk. It will infer. You don't have to, but I'm just showing how it is used. How it is used. So I could be a string, and now the string will be my name. So those are generic functions. There's also
multiple parameters.
you just do, how do you do multiple parameters in a function? arg2 is going to be type 2, thing 1 and thing 2. Who was that? Shanu. It's parameters. They're parameters. Try to think of them as parameters. They're parameters. They're just not values. They're not values. They're types. Good. And now it's complaining that expected 2 type arguments. There we go. We put a name to the thing that I'm trying to describe. It's a type argument. Expecting 2, but only got 1. Okay, ready? We spoke about type aliases before. You can have generics in your type aliases as well. And these are basically, you're just creating functions out of your, you now all of a sudden have like type factories, if you may, where you could create other, you could like create sort of like these compound types, not really compound types, but you create other types. So I could say like, if I want to make a type of array of that it could be anything, obviously this is built in, so it's just an example, but like I could have an array of numbers by say array of number. So I'm passing in the type argument, it's going to get assigned to that t, it's going to return it's going to return an array of t's. So I can have an array of numbers, I can have an array of mortys, if you so desire. I can make like a list that has like data, whatever. I'm just like, again, it's like they're parameters for your types. So here it's, so if I do a list, you know, const list of list, what? I got it. So you said you could see from back there. Apparently you can't. And I'm going to say it's of type number, a list of number. So it's going to say, well, it's declared and never read. Oh, because I did const. Let. Only time you should ever do a let is when you're demonstrating TypeScript. So it's saying it's declared but never read. But if I were to like assign stuff to it, it has to be object. Bam. So you see my editor is helping me. Oh, it's all the way down there. I'm sorry. Oh, Pretty's gonna knock it back down. My editor is helping me right away, and it's going to say data. It's going to be an array, and obviously this has to be a number. If I put in a string, it's going to complain. But if I put in a number, it's all good. Good?
Are these type parameters present at runtime?
I'm sorry, say that again?
The type parameters, are they present at runtime?
They are absolutely not present at runtime. That's okay, I'm going to bring it back. Like I said, this is the most important slide you will ever see when you're learning TypeScript. The truth. TypeScript does no type checks at runtime. Does anyone not know this meme? Okay, good. It's only been like 20 years since that. Say what? What do you mean? That has actual code? No. No, because everything, TypeScript, you write your TypeScript, you pass the TypeScript compiler, it spits out JavaScript. Plain old JavaScript. If you go to TypeScript Playground, which I'm not going to go to now because it's going to mess up my whole monitor display, you can actually see like what the compiler outputs. The compiler outputs just JavaScript. There is no types. This is purely to help you while you're developing. right? Like you saw, like right over here, like you know, it helped, like your editor like gives you like a lot of choices when you edit. Like for example, over here, like I typed this as a person. I like sort of didn't like show this in action, but like if you see this, like my editor gives me the choices of age and name because it knows I typed it as a person, so it knows that it's going to be either age or name. Let's put that back because we don't want to. All right, good. Don't worry, we'll see a lot of this. So here's what we're going to do now. Ready? Let's get rid of all the types that we wrote in the intro. All right, so I'm literally, you'll think I'm crazy, but we'll literally take all this. Hope that my edit, there we go. Okay, ready? Let's get rid of it. After lecturing you that you have to write TypeScript, look at this. It still says that it's a string. In fact, if I do my name is a number, I get the same error that I got before. Number is not a signable type string, but I didn't type it. Doesn't have to type it, right? So this is like the first awesome sauce of TypeScript is that if it can infer your types, it will infer your types, right? In Java, you have to like spend your entire life trying to like make the compiler happy. Like over here, it's like the compiler is just like the compiler will only ask you to help if it really, really needs your help, and it's really there to just like make you happy. But like you're never with TypeScript, you're never like fighting to satisfy the compiler. Like, I mean, obviously there are times where you have to, but it's usually only like when you really have to. Question?
How do you know it's not type LE?
Oh, that's a great because what do you mean? It is typed LE. The answer is whether or not you use let or const, right? Because let, by definition, you could reassign that variable. So then it will say, I'm not going to say that it's LE, it's going to be a string. But if I say const, which const can't be reassigned, so then it actually will infer it as a type LE. That was a great question, right? So if I do this, if you want to know why I said before that I only use let when you're demonstrating TypeScript and not in real life, right? Because really you should use const pretty much everywhere, except when you can't, which is like hardly ever. But do I sound very opinionated? I never knew I was so opinionated. But if you use const, it will infer it as the what's it called. But I'm going to put it back to let. So same thing over here. We're just going to keep deleting. Good. So my list also delete. Still an array of numbers. It was able to infer that. Tuples, because they're not really like things, so that you still have to. So here, interesting the way it inferred it. It inferred it very interestingly. It inferred it as an array that each item could either be a string or a number. That's just the way it works. Take it or leave it. That's because tuples are not really a type. Tuples is just like, it's like you could cheat with arrays to create tuple types, but they're not. They're coming, right? Are they? No, records are coming. There's something new coming in TypeScript, but what? Oh, it's a JS proposal there? I'm not the, what's it called? All right. Union types, obviously, there's nothing I could do about that because there's nothing really, you can't infer a union type yet. But for now, you can infer a union type. Let's delete this type. Oops. This is still inferring it. There we go. It's still inferring it it's still inferring the structure. So functions, obviously, you cannot take this away. This just won't work.
The last thing, when it inferred that structure, that means you can't add more properties?
You cannot add more. Oh, so you can. Well, you can add more properties.
You could put it like a
Age. What's it called? Occupation. Occupation equals. So I think it depends on your editor. Right now it's complaining, but I think it depends on your TS config. That's what I meant. Editor TS config is all the same thing. It depends on how strict. TypeScript is very much opt-in and very much has a lot of control over how much has a lot of control over like the level of strictness, like how strict do you have to be with your types and stuff like that. The whole talk within itself.
Wouldn't it be a subtype? Why would it not be valid?
What do you mean?
If you have something that has an extra property, it should still be a subtype of something that has. Well, this is mutated.
But this is you're mutating the other type. You can have. I mean, theoretically, what you're saying is true, but it's how. What do you want to do? You want it to re-infer the type of you're mutating an object. You want it to re-infer the type that you assigned it already. The inference happens when you assigned it. Then you're mutating the object. It's not going to rerun. It's not going to rerun the inference based on. Then what's the point of typing? Then what's the point of typing in the first place? What's the point of the type safety?
The same way all literal numbers are subtypes of numbers. something is typed as number, you could assign it to anything that's a subtype of it.
Okay.
And the same thing with anything. If you have a subclass.
Okay. Okay. What you're saying is, yeah, I could reassign this. I could now say job is, doer of stuffs. So this is complaining, but again, it's just because it's a TS it's a configuration. You can configure TypeScript to be okay with this.
This is a recent thing that they turned.
What that they turn right. It used to be what right. It's a configuration.
If you created that object as a different variable, you'd then be able to assign it, right? It's probably because then you wouldn't be able to get the property out again.
Let's talk later. No, I just okay. So variables you cannot function arguments. You cannot remove the type. There's no way to infer a function argument. You can infer the return type, right? It still infers it as a string because it actually just looks at your code and sees that you returned a string, so it can figure it out for you. So whether or not you should actually do this or not is up for debate. There are pros and cons to either way. Like some people say, no, be explicit about your return type. That way, your function, the actual, it sort of gives you type safety when you're implementing your function. Other people say, no, the type safety will be at your calling code. Like your function is your function, meaning the type is decided by the way you implement the function, and then your calling code will have type safety. Either way, it's fine. Either way, you'll have type safety. It depends on whether or not you'll have it in your function in the implementation or over there. But the point is that you don't have to write your return types. It will infer it. Type aliases as well. I think we showed that previously. Yep. So again, I can remove this. I can't remove this. Fine, we're good. Generic function. So this goes back to what's it called? What you were saying before. Oh, I have two. You see, Akiva. What to do with you? There we go. So this goes back to what you were saying before. So it's a const. Let's make that a let again. So again, I didn't have to who asked that question before? I forgot. There you go. No, you absolutely don't have to. There we go, string. So thing is a string, identity takes a string, returns a string. Interesting, it's inferring the actual function invocation as LE, but it makes no difference. It returns a string. That's probably just a weird editor thing. Because it doesn't type this as LE, it types it as the what's called. Type reference with type, this stuff, nothing really to do over here yet. So main point of this section, we just got the basics of TypeScript. That took way too long. We got the basics of TypeScript, and we saw that you really don't have to add your type annotations. TypeScript will add your types, will add the types for you if it can. Yes?
If a function returns different types, is that
it will complain. Oh, like polymorph, yeah. I mean, it can infer the different. It can infer, yes. So you want to know, hey, if name is Ellie, so then you return, I don't want to tell. No, I'm going to return a number, different type, right? I'm return, I don't know, return 1, 2, 3. So you want to know if it inferred it, and it did, yeah. So it will infer, if you have multiple returns, it will infer both. Good. Okay.
Wouldn't it be better if you left the types in?
Types in, why?
Then it will be
You think you're smarter than the computer?
clearer for anybody else that's looking at your code.
So, but you're hopefully they're not using text editor Sublime. Hopefully they're using VS Code or they're using a modern editor that information will be there for. I mean, all the information's here. Okay. I'm saying. But does the benefit come when you're reading the code, or the benefit comes from when you're working with the code? When you're working with the code, the editor will give you feedback, right? What was that? We're inline also, yeah. There we go. So I'm using VS Code just because whatever, but I usually use WebStorm, and different editors will use the language service in different ways. But there are footcons. You could get yourself in trouble, first of all, with writing types. Most of the time, you're only writing the type because because of the inference, right? So like you're doing extra work, right? If you think about it, why? Here's the question. Hashkaf Hakir, right? Is the type a string because I said it's a string, or it's a type of string because I assigned it a string? Right? Because I assigned it a string. So then the computer knows that, so let the computer do that. I mean, the compiler knows that. Why am I telling the compiler? I don't know. Is it better? That's what I'm trying to say. Your code is your code.
You decide that this thing is not supposed to be a string, it's supposed to be a number.
Right.
But I'll change it.
But I'll change the thing, change the type, and change the what's it called? Like what? My point is that you're not smarter than the compiler, right? And but your editors. Okay, we could talk about this for hours. I'm not saying it's a bad question. I'm just telling you what right? No. But documentation is deliberately for. But here I'm trying to say you have. Okay, yesh. Okay. Are we ready? So that's the first half of my talk. So now we're going to take what we learned and we're going to apply it. And maybe you know what? Maybe once we see what else you could do with inference, not just. I mean, these are all just like very silly. Most of the time, you're not assigning literal values. You're getting data from other places. Data's flowing through from functions and places and whatever. Okay. Here's a get function. A get function takes an object. It takes a path. Takes a key in that object. We'll call it, or path. Yeah, we'll call it a key. Just take a key in the object, and I'm going to return the object at that thing. Very simple. Now, I'm not saying you should write this function. This is like load-doc, right? Load-get or underscore get or whatever you use, or whatever you shouldn't use. But no, so this is just sort of as a case study, if you may, right? And this is going to be the rest of the talk. We're going to try to see can we make. So I have so I work for Northwestern Mutual. So we do financial simulations and financial planning, just all for the sake of selling expensive life insurance. So here I just sort of took like a very deep object that we mangled it, whatever. And it's a very deep object. We have all different types. We have like deep objects with strings, with numbers. So this is a simulation for Jerry and Gail. 10 points if you know who that is. We have like the simulation years, like the amount of years that we're simulating, trying to project their financial, here we have an array of accounts. We have two types of accounts, a taxable account, Roth 401k, whatever. We have an array of numbers over here. We got some nulls. We got some empty arrays. We got lots of, it's very deep with objects, arrays, all different types. So I'm just using that. So if I would want to get the input dot, I forgot what I wrote already. The input dot house. So first of all, you see I have to actually keep checking. I'm not getting, the editor is not helping me at all. Client dot name dot first. First? Did I spell it right? I didn't spell it right, right? I don't want to have to do that. I don't want to have to keep checking. I don't want to have, If we just saw that we could infer everything, why is my editor not inferring how I'm dotting into this thing? So that's going to be the case study. Could we figure this out? So we did not learn enough about TypeScript yet to know whether or not you could do that. So first of all, okay, so we did know. We know that we could infer the object. We learned about generics, right? So this is going to be the type of the object. Type of object. So that we learned. So we know that could be the type. Right away my thing is complaining because any in the type, index type is unknown. It says you're taking any, so any is like the top type. Any is basically where you're opting out of the compiler and saying this could just sort of be anything. So we know this is going to be a string because we saw it over here. It's still complaining because it's going to say, I'm not going to read that whole thing. But the point is, it's still saying, you're saying this could be any string, but who says that any string in the world is a valid property on this object? That's this type, right? So we're sort of in trouble over here. So we're going to learn a few more stuff about TypeScript. I'm going to pick up the pace a little bit because am I really out of time? Wow, I am very much out of time. Okay, ready? So I'm going to start cutting and pasting code, if that's okay. No, we're not. No, I'm not going to cut and paste. So key of operator. So what's the key of? So we're going to learn a couple of operators. Now operators basically, so the same way we have operators or functions in within the regular programming domain, TypeScript also gives you ways to hook. I made up the word operators. That they're hooked sort of you could hook into the inference engine, right? So if I have a, you know what? I'm going to do type of first. So I'm going to do type of first. Remember we had the person over here? So we had Shia. Did I copy that? Oops, I did not. Right? So it inferred it. It inferred the type, but I lost my identifier. I lost my type alias, right? I want my type alias, but I don't want to have to retype this because, like I said before, right? Remember our is it a type because the type or is it a type because the object? So I could say type of other person. Same result. So now I have a type alias with an identifier by asking TypeScript, hey, what did you infer as the type? Type of is saying, hey, TypeScript, what did you infer as the type? Assign it to a type variable. Okay.
That way, not just why are you doing inference and not just type?
Because I'm trying to demonstrate over here. So this is a trivial example, but But now I'm going to go out of order because I don't know how to count. So now I want to get right. If you think about what we want over here by our case study, what do we want this to be? We want this to be either input or I think goal progress. Goal progress. That's what we want to get over here. We want to get all the choices that we have for the keys on this object, right? We got input and goal progress. Input, goal progress. Good. So I could say, okay, I want to get the type of the keys of person is the key of person. So now I have a union type of the string literals of the keys of the type that it inferred from that object. Okay? Of course I can. So now I have the key of the type of the other person. Okay? So I still have that, right? And finally, I also want to get the return type, right? So I want to be able to say, can I look up a specific type? So I could say, I want to get, hey, what is the type of other person.name? I want to get string and number. So I could say type of name is what? What is it? So we got to get, so first we get the type of the person, right? And then we're going to never write this, but, and I'm going to say, oh, look at that. We got some autocomplete. I'm going to say age. What is the type of name, or age is number, but type of name, like, it's like you literally, it's like you're programming over here, right? Like the same way you could like use bracket notation to like get into your objects, you can use bracket notation to get into your types, and you get the type of the type at that thing. So we got type of other person. So now we have everything we need to get a types. Now we could go to our Lodash thing over here, right? So I think we have everything that we need, right? So we have the type of object. I'm going to start using like just single letters because it takes me a long time to type. So the object is going to be just t, right? The path is going to be what? It's going to be a key of t, right? And now, ta-da! I have autocomplete, right? So I can say my input. Now, what's my return type? Return type, it's still going to be any, but my return type could be, I'm going to take t, and I'm going to get what? I'm going to get that same key of t. And now, input is, whoa, it inferred that whole object. The whole object in input, it inferred that, right? So you see where we're going over here, right? So we just like inference all the way down. So you notice like, what was that?
You're only one layer deep.
Oh, very good. It's only one layer deep. What? What do you mean? Oh, input, yeah. That's what I was talking about, input. Oh. Oh. Yeah, but it's union type of. Oh, very good. Because it could be any. Very good. So it's not the actual thing. So remember we said before, should you be explicit? Should you not be explicit? Let's not be explicit. And now, oh, it still had the union type. Okay, so we don't have this yet. So what was that? I could do generic. Okay. Very good. We'll get there. Okay, so far we got one layer deep. Now we got to go 2 layers deep. So what do we need now? So just some pseudocode. What do we need? We need a bunch of strings. We need input or input dot household or goal progress, or goal progress dot retirement. We have to know when Jerry is going to retire. Gary. Progress dot retirement. Oh my gosh, I can't believe I'm typing like, whose idea was this? I spelled it wrong. Right? Can we infer this unit? So we saw we inferred this union type. Can we also infer this union type? So let's go a little further. We got 8 minutes. Okay. So here we're gonna actually. So in order to be able to do this, we sort of need to start asking questions about our types. We're gonna say, okay. Let's go back to input over here. So you inferred this. You inferred you inferred the return type as this big object, right? But in order to know whether or not to give to give another, I guess, option if you made to this union type to sort of build up this dot notation, I need to be able to say, like, sort of ask the compiler, hey, are you inferring this thing as an object? If you are referring it as an object, so then I'll do more magic, which I'll show you in a second. But the point is, how do you ask questions in code? How do we ask questions? If statements. Don't use if statements. Conditionals. Ternaries, right? We use ternaries, right? So the same way you have a ternary in programming, you just have ternaries and types, right? So you're literally like writing programs in your type. So I could say type is a string. Now this is a type constructor like we saw before. So I'm going to say, hey, is this type a string? Well, I'm going to, hey, does it extend a string? If yes, return the string literal yes. The type string literal yes. Otherwise, return no. So now I can write a function. And by the way, here's the syntax for your arrow function before he's in the kitchen. I'm going to say, hey, is this a string? This is an arrow function. Now I see where my mistake was before. I did an arrow instead of a colon. Okay, so here it's the x is going to be of type. This is the argument. It's going to be of type t. It's going to return whether or not it's a string or not. And then my implementation is this is just JavaScript, right? Now, ignore that for now. This is because to get the compiler happy. I'm basically over here. I'm specifically relying on the type engine is not really strong enough to infer this properly. I don't know why really, but whatever. It's not. So here I'm actually relying on my type annotation more than on the implementation. So here, like, you have to write it. But conditionals are very helpful when it comes to describing like the relationship between inputs and outputs and stuff like that. What was that? I could do as const. I don't think that's gonna help. No, that's not gonna help. Const is just gives you the shape. I'm not sure why this doesn't work, but the point is, point still stands. We have conditionals. Ready? So now we know how to ask. So back to our case of our get function, we type input. And now we know that we could ask the compiler, we say, hey, did you infer this as, we could say, like, here we're extend string. I could say, hey, did you extend this as a object? I now have the ability to ask that question of the compiler and then do different stuff while constructing my type. But I also need something else. I need to be able to create a string with that dot notation, right? This is something, you cannot do this in Java or C#, all you people out there. Oh, I just realized this is, see, I gave this talk before this was controversial. I gave this talk like a month ago. So here we have type world is world. We have greeting. So now we're at type. This is not JavaScript. We're still looking at types. We're not looking at JavaScript code. We're looking at types. I create a template string just like I do template strings in just like I do templates in JavaScript. I interpolate the type in there. So now the greeting is the type of the string hello world. So you see where we're going with this. We can build up strings. Here, if we have two different union types, and then we create a template, and then we create a template string passing in the union type, it's going to loop through all that stuff and give you all the choices. Over here, we have red, blue, 1, 2. So now we have, this is very non-deterministic of whether or not it's one fish, two fish, red, blue. I don't know. Sometimes I do this. It could be because whatever, it knows what's going on in the world right now. So it knows to not. VS Code is very smart. Okay, use VS Code. Don't know WebStorm. So it could be that's why it's what's it called. So now we have enough to at least get one level deep, and then I'm going to cut and paste the code to get the recursive part of it. So very good. Okay. So I'm going to start pulling things out into types over here, and we're going to do this in 3 minutes. We're not going to do it in 3 minutes. We go over there? We go over there. I'm in charge. I go over there, right? All right. Okay, so we have the object. And I'm going to now say this guy is a path. No, so I'm going to say the path extends a path of t. Now, path of this is going to be like, I'm going to start introducing some new types over here. So I'm going to say, hey, get me a valid path of the t. Okay? So now I'm going to say, okay. I'm going to say, I'm going to say, oh, I'm sorry, I need 2 things. Extends up, hold on a second. I'm embarrassing myself over here. Path extends, right, it's going to need 2. Path, there we go, path of t, and then I'm going to add another thing. Okay, there we go. So I'm going to say, hey, is this a path of that? And then I'm saying that this path variable, which is going to be the type annotation, the type variable for this type is going to be, I'm going to put this back to Andy, by the way, is going to be extend of that. So what's that? So I'm going to say, okay. So the first thing I'm going to do is I'm going to say is t. Oh, by the way, so this obviously has to extend a key of p. That's the first thing. So I'm already constraining and say, what pt? Thank you. Great, you guys are listening. All right. So first of all, that's the first thing. Let's constrain it to that. So now let's say, hey, let's get the value. Let's get the type value. We're going to say, hey, does it extend something? Do that. Otherwise, just return p. Okay. So now, if it extends what? If it extends, so I'm going to say, does it extend I'm going to introduce like another type over here. Does it? So you could have a record type. So before I was showing like type literals for type aliases for like object literals. So you could also have like a record is just a built-in type to sort of declare this is going to be like the key and this is going to be the value. So I'm going to say, hey, does it extend any of this stuff, right? Does it extend an object? Does the type at that location extend a record? Basically, does it extend an object? That's basically what this says. In English, does it extend an object? Now, if it does extend an object, so then what do I want to return? So first, I'm going to return p. Also, I'm going to return. Obviously, I still want input. So in this case, let's imagine our case before we have input. So we say, yeah, input extends. Input is an object. Input in the financial simulation is an object. So if that's the case, it could be p, or it can be. Let's build up a template string. Okay. So first, it's going to be p, and then it's going to be dot something. What? The p has to be in the, thank you. So we're going to say p dot what? P dot, this we know, the key of t of p. Very good. T of p, right? So now it's complaining over here because this type is a little too wide. So I'm just going to satisfy the compiler for a second over here. Bear with me. I'm just going to ignore the @string for now. That had to do with what's it called? Why is this complaining? P is not assigned with the string number. Oh, okay. The problem is I'm doing this a little backwards. So I'm not going to get into the details of why it has to be done in this order. But really, the first thing I had to do is I have to do a nested turning over there. Because the first thing I have to do is take care of whether or not it's a string or not. If it's a string, so then I have to return. Right. If it's extends, I'm missing, then otherwise return never. Okay. It's 9. Well, I'm missing it. Say what? Right. Oh, thank you. There we go. Okay, perfect. There we go. It's still complaining about that, even though T peak extend string, and then it does that. This should work. It's saying P. I don't think I extended it properly. It sure what? You're right. If this extends a string, thank you. Perfect. Thank you. Who said that? Thank you very much. Yes. So first you have to check this. Make sure that I'm passing in a string. Once there we go. Now we got it. So now we can infer. So I still this is so path of there we go. Path of object and key of object. And now, there we go. That took a while. Okay, sweating over here. Could you see? Oh, it's all the way at the bottom. All right. So now we built up our what's it called? We have Go Progress, Go Progress, in the household recommendation simulation. We built up this again through extends and templates. And sorry that took more than 3 minutes, but we have. So now we inferred all this stuff, and we don't have the return type yet, but we also only have one level, and we want to get a lot further into here, right? So the same way we have recursion in programming, we have recursion in types. So we're going to say the type, not the type of T, the type of T, the P of T, and then does P extend, thank you. And I still need that stupid and I need this. I still need to constrain that. No. Whose idea was this to live code? Extends P, so it's a path of that, or no. Or what am I doing? Or the key of, there we go. And, oh, hold on. Yeah, here we go. No, I almost got it. No, I didn't get it. Yes, I did get it. I did. Check that out. Go prioritize items and accounts, all items and accounts. Ta-da! All right. But I'm not done, because the return type is still any. So I'm just going to cheat and go to the last file. But this is like the final version of this load that get where so this is that same function that we had before. We have T, we have P extends the path of T. This is the exact same. This is what I did before. I refactored a little bit to like move out when you like moved out like the base case to a different type. But basically that path recurs the exact same thing that we wrote before, just a recursive path. And then we also have the value. Now the value, and now when I do simulation, so now it's inferring it as an array of numbers, right? Because the simulation years are actually an array of numbers. If I do, if I do like the household partner name, the given name of a what's it called, it will infer it as a string, right? So basically, this was the last thing I was going to show, but we're out of time. But basically, it's all the stuff that we learned with one additional keyword of infer, which is a whole Langomeister in itself. But basically, what we're saying is the same exact. The value, we're asking for the type of the value at a specific path. So we're saying the path value from this object, the path value of this P at this T. So we say, hey, does it extend a dot notation, right? Does it extend a template string that has a dot in it? If it is, so then is it the top level? Then yeah. So then what about the rest? Is the rest also a path within that file? If yes, so then just recurse, just like further recursion, get the path value from that object, that object at the rest. Otherwise, it's a never. We didn't talk about nevers. Otherwise, we're going to ask again, hey, does P extend the key of T? If not, just get the regular type. This is what get the type at that value. That's the lookup type that we saw before. And now we basically, finally, with type inference all the way down. So you notice over here, so the main point is, going back to like what we spoke about before. This is pretty heavy stuff, right? But everything that's in here is in like just a few times. We're just scratching the surface with TypeScript. But all the topics that we learned today, key of, type of, conditional types, template literals, generics, generic types, generic functions, recursion, all that stuff is all included into here. The infer keyword is just it's just part it's part of conditional types that we didn't really get to talk about, but it's all here. And the point is that in my userland code, there's no types over here. Like in this line of code, I'm not sure if you can see it because it's low down. In that line of code, there's no types. There's no type annotations. I typed everything at the edge, like we like to call it, like TK taught me to refer to it as. It's type your functions, like type things at the end, and then like let inference like work all the way through. Like this method, it's inferring the entire type of that object. When you pass it into the function is inferring every possible dot notation. Obviously, I had to write a type in order to do that, but the inference it's still using inference. It's still using inference, you know, at the point of using it, at the point when you're using it. You're still using type inference, and it's inferring the value. So now I have value. It's inferring the type of the value. So now I have typed my value without writing a type annotation. I was able to get type safety. If I make a spelling error in here, my editor is going to complain. So I know I said I'm not going to talk about type safety. I wasn't going to talk a lot about it, but like you see over here, like you sort of like you get your type safety without even like writing like the type over here when you're using it. Like you take this function, you pack it away in your library in your library of code, and then you forget about it, and then like hopefully. So over here, obviously, like this is an inline object, but hopefully you're typing, let's say your database or your API calls, you type those edges so like it could just like infer like all the way down, and like in your actual, the developer, I personally, the developer experience that you get with this style of typing, where you're not really typing to satisfy the compiler, you're typing to sort of get the language to help you, right? And like it's you end up getting a lot of type safety without actually writing a lot of type annotations in your userland code, which I think is pretty cool. But I'll let you guys judge that for yourself. And with that, thank you for listening.